Hi, welcome to my channel. In this video I'm going to show you how I constructed this belt grinder.
Let's start with a 3D model created by me earlier. It allowed me to predict the alignment of components and their mutual interaction when in use. What distinguishes my machine is the application of Arduino microcontroller to the following things: the interaction of the operator with the grinder, setting the working parameters and reading the actual parameters, ensuring that the actual speed is maintained, tilting the guide wheel to make sure that the belt is in the right position, and ensuring the proper tension of the belt. Let's now see how the whole thing was constructed.
Welcome in the garage. Let's start the assembly process. All of the parts I've created in 3D modeling software, I've ordered laser cutted. I have cleaned them with a wire brush on a drill press, and then I've touched all of the edges with a file to make them smooth. Now I have to take care of the third dimension, because as you can imagine, laser cuts only in 2 dimensions, and the third dimension is the thickness of the steel. So if I want to make some holes in this third dimension, I have to do them myself now. Let me set an example. This is the bearing holder, and it should have a screw hole which is tapped and countersunk right down there in its third dimension. So let's move to the drill press and drill that hole.
The process of drilling a hole might seem simple, but a few vital steps have to be taken. First things first, the location of the hole has to be marked by scribing of a layer of steel blue tracing fluid. Then the marked location has to be center punched. Drilling and making a countersunk for a screw head are almost the last thing to do. After making the inner thread by a tap, it's time for a quality check with the appropriate screw. Not everyone knows, but by using combination of Ctrl+C, Ctrl+V on your keyboard, you can make multiple copies of your operation. The parts I have just made are components of an important subassembly. In common belt grinders available on the market, there is always a small adjustment knob. Turning that knob leads to tilting of one of the wheels. That wheel, which is out of the alignment, leads the belt to its side, compensating for belt or machine imperfections. In my grinder, the operator will not have to adjust the belt position. Instead of forcing him to do this work, the grinder will adjust itself automatically by rotating the stepper motor, which is the part of the tilting tensioning mechanism which you see me making right now. After making this, I mounted the hollow M10 bolt on a stepper motor shaft and secured the motor to the sliding bracket with 4 small screws. I also modified an M10 nut by drilling it crosswise. By 2 screws with outer diameter smaller than the holes in the nut, I created a sort of a hinge, which leaves the nut with 1 degree of freedom, allowing it only to rotate around the screws. Then, the bearings were inserted and set in place by the clamps tightened on them.
I am very pleased because I have finished making this assembly. Of course, I have to give it a paint job later on, but mechanically it's ready. This is responsible for compensating in any imperfections in the whole grinder build. It will do that by tilting the guide pulley left or right to move the belt to the center. Now I have to move on to the next part of the build, which is making the frame. And I will do that frame using 50mm by 60mm box sections, which I have right down there. Okay, so I've prepared all the material, I have cut all the necessary parts to make a frame, and I have painted the faces of the steel with the steel blue to mark the places where to drill out the holes. When these holes will be finished, I will move on to the welding process and weld the frame.
After having the last part of the frame welded together, I sent all of the ready components to have them powder coated. Now you can see me manufacturing the shafts for 2 of the belt wheels. I used piece of the chrome coated rod with outer diameter of 20 mm, which is available on the market. Using a handsaw I cut it to the length and then I drill it through and tapped the hole. Off the record I welded the bracket, then I connected to the aluminum bar with 2 M10 screws. Freshly threaded rods fits into holes in the bracket where it's permanently secured with a circular weld.
I have finished making this pulley holder and I really wish it would be straight, but it will occur when everything is finished. The rest of laser cutted part still need my attention, but I have received a painted frame. I have it powder coated and I'm really happy with the result. Now I'm going to move on to the next step, which is assembly of the frame and the ready parts and some bought parts, like for example the electric motor. Then I'm going to use the ready parts as the reference point when welding these parts right there. This will make things a little bit easier because the metal tends to shrink when it's welded and you really can't predict the exact dimensions after welding. So when I will use the frame as a reference point, I really wish that everything will fit together nicely.
By the time you see me assembling the grinder, I will try to anticipate some of the questions that might appear in the comments section. If you are curious where I bought the electric motor and the inverter, who laser cut all of the parts for me and where I had all of my welded components powder coated, I link you the name of this company in the description. It is the Polish company Złoty Kłos. They ship worldwide. They have a well-equipped production hall and very affordable prices for electric motors, inverters and many more items they have on offer. So if you are going to make similar machine to mine or order all sorts of machines ready to use, I strongly recommend this company.
Unfortunately, I don't have a lathe, but I have my 3D CAD model, so I could prepare all the technical drawings and order all the parts which need to be turned out of steel. I have a traction wheel which will go somewhere there. I have also the 2 wheels which I have to press the bearings into and then mount it right over there. Moreover, I have this big wheel which will go on the motor shaft, and about the shafts I have also a shaft which will be pressed inside this wheel and that whole assembly will sit over there.
To assemble the machine in the above mentioned way, I had to fit the traction wheel onto its shaft and use a snap ring to set it in place. Then I inserted the shaft into BF bearing blocks and secured them to the base.
The next step is to drill a hole in this blue marked surface in this pipe holder to mount it right there. This should hold this linear actuator which will be mounted there, and it will be used to push this sensor, which in result should tension the belt like that. Because the step with mounting this actuator is quite finished, I will move on to the next, which is try to press bearings inside these two steel pulleys using my vise, because I don't have a press.
After pressing bearings inside the wheels, I mounted them in place according to the 3D model. On the shaft first goes the washer to keep the bearing from the steel plate. Then goes the wheel with bearings and another washer and a screw to prevent the wheel from sliding off the shaft.
Off the camera I have welded this element, and I wanted to attach it to this pulley holder. And these pulleys should be flat with that surface. So I'm using this box section to align it, and it should go like so. Yeah. And now I'm going to use some M10 by 30mm screws to hold it together, like so. Okay, it's almost ready. And finally, it's the moment to put the belt on and wire it, at least temporarily, to check if everything is kind of straight and if everything will work. As you can see, I have disassembled this machine a little bit, because I have to have all these small welded parts powder coated to match the look of the frame. What I'm going to do now is to wire this tilting mechanism to check if everything works properly. It was not without difficulties, because electronic part is my least favorite part, but it finally works. But there is still a small issue. If I put my hand on top of it, when it moves up, I can stop it with the force of my hand. And that is not acceptable at all. What I'm going to do to fix this problem is to change this motor for a bigger one. Because it's NEMA 17 standard, I can fit a little bit bigger motor right down there, and it should fit the old bracket. So I won't have to re-weld and remake everything once again.
After ensuring that the guide wheel tilting mechanism works, I moved to mounting the plastic box for the electronics. I also installed infrared proximity sensors. I cut some aluminum extrusion according to the 3D model. Then, using rivet nuts, I secured them to the frame, and in other places I used dedicated mounting points which were prepared beforehand. The rough endings of aluminum extrusion were covered with plastic end caps, which is not only safe but also looks neat. After making all the necessary electronics connections and hours of programming in Arduino IDE, the grinder was completed. no DIY grinder construction video is finished without the pencil lever test, which you can see me now doing. Thank you for watching, please subscribe and share the video. See you in the next one.